Hello my dear students, how are you all? Look, today I'm going to teach you a topic from chapter number 23, and it's all about producing ethanol. You know why ethanol is produced on a large scale? Because it is consumed in very high amount, and due to its consumption it is manufactured industrially, so its demand is very high. And today video lessons will be explaining in detail the production of ethanol by two methods, one from ethene and the other is the old conventional method by using fermentation. So I advise you to watch the full video to understand the topic thoroughly, so that you'll be able to answer the questions from the textbook as well as your past papers. So here we begin. You see, the production of ethanol is a very large industrial method where very big tanks are required for the production of ethanol. So the first method is manufacturing ethanol from ethene. We had discussed this reaction before when we studied the reactions of ethenes, and we studied about addition reactions. So you see, this is the main method for the industrial production of ethanol. And how we prepare? We in fact add a molecule of water at high temperature, which is rather called as steam, because the temperature required for this addition is 300 degrees Celsius and the pressure required for this is 60 atm, and phosphoric acid is used as a catalyst. So when we write the equation, it goes like this: molecule of ethene is C2H4, which can be written like this: C double bond C H H, and to this hydrogen, to this carbon, two hydrogens. Okay, when we add a molecule of water, water is a liquid at room temperature, but you see the temperature is very high and the pressure is also high. So at this condition, in the presence of phosphoric acid H3PO4 as a catalyst, this molecule of water saturates this unsaturated molecule of ethene to give us C2H5OH, that's ethanol. Okay, so here we are getting one product by combining two species. So this is a kind of addition reaction. And to understand this reaction structural differences, you see a molecule of water or steam like this. So hydrogen goes to one carbon and this hydroxyl group goes to another carbon. So we get CH3, next comes CH2OH, and what it is? This is ethanol, right? So this is a simple addition reaction, and we can also call this reaction, because a molecule of water is added, so we can call this reaction as hydration, which means addition of hydrogen water. Okay, now another very important topic from the examination point of view is producing ethanol by fermentation. You know, alcoholic drinks such as wine and beer contains alcohol, and to produce ethanol we used to ferment fruits, vegetables or grains. And alcohol fermentation is a process in which microorganisms such as yeast act on the carbohydrates or sugars like glucose, but in the absence of oxygen, to produce ethanol and carbon dioxide. So here the main interest is the production of ethanol, and that is C2H5OH. So it is one of the oldest method, more than 10,000 years old way to produce wine and beer. How come? By decomposing sugar molecules. You know what sugar molecules are? Sugar molecules are, in fact, the polymers of glucose, C6H12O6. So when this sugar molecule is decomposed in the presence of microorganism found in yeast, this is a bacterial action. So this decomposition produces ethanol and carbon dioxide, and you can see very big containers are required for this process. And what gas is coming out? Carbon dioxide. So when the reaction is performed by the action of bacteria, one alcohol product is there and the other one is carbon dioxide. So when carbon dioxide starts producing, it begin to froth up. So this froth tells us, indicates us that the work is done. Now chemically we see the reaction as, you see the molecule of glucose C6H12O6 in the presence of yeast, which is working as a catalyst because it has a special enzymes in it which are going to catalyze this reaction, so that ethanol is produced and carbon dioxide is also the byproduct. Now question, can we perform this fermentation process in the laboratory? Yes, you can see the apparatus in which a conical flask is taken with sugar and yeast solution. So this solution is kept in absence of oxygen. So you see the cork is placed so that oxygen does not get in the flask, because this is the process which is performed anaerobically. So you see the sugar molecules will start decomposing and ethanol will be produced, which will remain in the liquid state, but as carbon dioxide is a gas, it will escape and it will come to the test tube where we have taken lime water. You know why we have taken lime water? Because lime water is always used to identify the presence of carbon dioxide. So carbon dioxide, when it will be reacting with lime water, we will get white precipitate. So the formation of white precipitate will confirm that the production has done. So this is what we need to identify, what are the raw materials for it and what are the suitable conditions for this reaction and how we are going to identify it. You see, the typical conditions needed for fermentation include the sugars must be dissolved in water and mixed with the yeast so that the raw materials are mixed together well so that the reaction will proceed adequately. The next is an airlock to allow the carbon dioxide out while stopping air getting in. And how this is done? Fermentation can only take place in the absence of air, and this is ensured by the following precautions. We are going to isolate the apparatus by using a rubber bung to secure it, to secure the mixing, to avoid the mixing of oxygen with the content. And the next is the lime water in the test tube prevents air from entering the apparatus, and the temperature required for this is 37, almost ranging between 25 to 35 degrees Celsius, so that the enzyme which is working for fermentation works best at around 37 degrees Celsius. And if the temperature is raised beyond it, the enzymes will be denatured and therefore will be unable to catalyze the reactions. So at higher temperature, fermentation will be stopped. Now you see the alcohol which is produced by both of the methods are in high demand because ethanol is used as a solvent, it is used in alcoholic drink, and it is used as a fuel. But one thing which should be discussed in detail here, that the ethanol which is produced here is only up to 15% in concentration, and this is because when the alcohol content exceeds the amount, the yeast dies and fermentation stops. So to produce high quantity of a greater quantity of ethanol, we cannot mix too much yeast because it dies when the concentration of ethanol as a product exceeds. So that is why we will be adding only a required amount of catalyst yeast. And the other thing, that ethanol can be obtained from this liquid product mixture by fractional distillation. So it's not the true and complete picture of fermentation that if we mix the yeast with the sugar solution, the ethanol will be directly produced. No, first it will be produced, then it will be separated by and purified by fractional distillation. So this is all about fermentation. You need to go through everything from your textbook as well. Now I explained this topic, how I explained you, and how my lesson was helpful. Please put your feedback in the comment box. And now this is your time to solve the exercise from the textbook. Test yourself 23.3 and 23.4. I will be coming with another organic chapter topic, and that's about macromolecules. So wait for my next video. Till then, Allah Hafiz.